Ferman's proton. An imaginary proposal, but one with conceptual and structural content and explanation. Friends, please excuse this somewhat crude and simplistic illustration, but for over 40 years, I have presented, explained, and even insisted, sometimes vehemently, that the electropositive charges of atoms are associated with and included in the electromagnetic fields and orbital structures that surround these systems, and are found within them, rather than being concentrated in their nuclei. However, I still have the impression that this proposition has not been seriously considered, since I have not received substantial responses, debates, criticisms, or significant acknowledgments on the matter in scientific forums or public discussions. To illustrate the idea, the following mental representation, consistent with the observations obtained so far, is deliberately simple and easy to understand. Let's imagine a hypothetical proton, greatly magnified, placed on my table. Let's suppose that several particles, hypothetical negatively charged electrons, and even positrons, are suspended from the ceiling by separate threads above this proton. If the thread supporting any of these particles were suddenly cut, according to the conventional model, the particle would be expected to respond to the electric field of the positively charged proton. However, in the framework proposed here, and also in everyday practical observations, it would not be attracted directly toward a positively charged nucleus, but would be attracted and held within an electromagnetic orbital structure surrounding the proton. It is this orbital structure, therefore, that in the present model constitutes the effective region in which the positive charge of the atomic system manifests itself. According to this interpretation, the same principle operates continuously in the countless chemical reactions that occur in the cosmos. Electrons are attracted, captured, and held by the peripheral positive electromagnetic orbital structures of atoms, rather than being attracted directly toward their nuclei, even in the case of free protons without an electron shell. A related practical consideration arises from laboratory experiments, chemical reactions of all types and scales, particle accelerators involving protons, and the interiors of stars in their plasma state. In these environments, protons appear to have access to a wide variety of atomic nuclei and can interact with them, contributing to the formation of larger or more stable atomic systems. Within the proposed framework, this ability would be difficult to reconcile with the assumption that protons behave simply as positively charged particles that necessarily repel each other electrostatically. Therefore, the proposed model assigns a different structural role to the distribution of positive charge within the atomic system, a compact or amorphous nucleus without well-defined particles, and a periphery with well-defined positive electromagnetic orbits at rotational radii around the nucleus. Clearly, this would represent a significant departure from some central assumptions of contemporary atomic and particle physics, including aspects of the Standard Model. However, there is no reason to consider this departure as inherently problematic. On the contrary, from the perspective of the current model, it considerably simplifies the structural organization of both matter and the cosmos, at all levels and scales. However, and simplifying the point of this article, we cannot ignore the obvious: if electrons are always attracted, move, settle, rest, and exchanged from electromagnetic orbits, including our simple experimental proton, it is because that is where the positive charges are located. Other theories or postulates are inadmissible to simple observation and structural physical logic. If Rutherford concluded that the positive charges were directly located in the nucleus, experiments and observations tell us that even if the nucleus could emit magnetic fields, the charges are located and act from peripheral orbits. Greetings, friends. Thanks for your interest.